Welcome to MedMath Part 1. In this first part of the series of MedMath, we're going to look at just the basic problems of figuring out how many milliliters you need or how many drops you need with a given drip set to give a certain amount of fluid. We will also begin to look at some of the slightly more complex as far as giving drugs. We'll save the rest for Part 2. Here we go. Okay, so let's start easy. You desire to deliver 1,000 milliliters. Using the given drip set, how many drops will you deliver? Let's see what the problem tells us already. I want to deliver 1,000 milliliters. Stick that up here. Alright. Doesn't tell me what that is over, doesn't tell me how much time, just tells me 1,000 milliliters, so we'll leave below that blank. Let's draw that line. But it does tell me, since I want to know how many drops, that's going to be my answer. So my answer is something drops. Alright, let's look at the label. This tells me I have 15 drops in 1 milliliter. So if I throw that in my problem, I have 15 drops in 1 milliliter. If you aren't sure where the milliliter and drops should go, top or bottom, consider this. I know that I want drops as my answer. So that means I need to have drops left over. If I look at this problem right now, I have a milliliter on top and a milliliter on bottom, drops being the only name I have left. So that's how I want it. If this was reversed, 1 milliliter over 15 drops, I wouldn't be able to cross them. And this is what I mean by cross them. If I cancel out anything that I cross on the top, I can cross out on the bottom. So milliliters, for instance, I can get rid of. I have a milliliter on the top and milliliter on the bottom. I really can't get rid of anything else. So this is what the problem I have left to work with. But the important thing is drops is the only remaining unit left. There's nothing else. So I know that I have this problem set up right because I'm solving for drops and I have drops left in the problem. So now we just do our math. 1,000 times 15, and that gives us 15,000. So let me throw this out here. And now I have 15,000 drops over 1. That's all I have left, 15,000 over 1. And obviously with math, anything over 1 is a whole number. So my answer is clearly 15,000 drops. I need to drip 15,000 drops in order to get 1,000 milliliters using this drip set. Alright, so let's do one more, a little bit more difficult. Using the given drip set, you deliver 1,800 drops. How many milliliters have you delivered? So we'll start by looking at the problem again. I know that I have delivered 1,800 drops. 1,800 drops. It doesn't really tell me anything else, so that's really all I'm working off. 1,800 drops. So we'll end that part right there. It does tell me how many milliliters have you delivered. So I'm looking for milliliters. That's important when we set up our problem again. So something milliliters is my answer. If we go to my drip set, 60 drops per milliliter. So like before, remember I said we can cancel from top to bottom, but we can't cancel top to top. So if I were to put the 60 drops here, I wouldn't be able to cancel the drops out. I want to put that drops portion of the problem where I can cancel it out because I want to be left with just milliliters. So we'll put the 60 drops down here so that I can cancel them out, and that 60 drops is 1 milliliter. So that 1 milliliter is 60 drops. So now I can start trying to cancel things. Remember, top to top we can't do, top to bottom we can, so I can get rid of this drop for this drop. I only have 1 milliliter, so the milliliter stands, which is good because that's what my answer is. And now, if I reduce this problem a little bit so it's easier to read, I have a problem that looks like this. 1,800 milliliters divided by 60. And all I did was multiply across the top, multiply across the bottom. So here's where I can cancel some more. I can cancel zeros, which is basically dividing by 10, here and here. 1 0 from the top, from 1 0 from the bottom. If I rewrite the problem again, now I have 180 milliliters divided by 6. And that's about as far as I can reduce it with zeros. I can divide more. Common denominator would be 2. We can divide by 2. So, or we could also, let's see, what other denominator? We could also do 3. We can divide by 3. 180 and 6 both divide by 3. So if I reduce by 3 again, and this is how you would do this in your head without a calculator. If I reduce by 3 again, so 6 divided by 3 equals 2. 180 divided by 3 is 60. So now I have 60 over 2. I can do it again. 60, I can do it by 2s, or I can easily do this in my head. What's half of 60? And that actually gives me my answer of 30 over 1, keeping that unit up there, which comes down to 30 milliliters. So without even using a calculator, I could work through those big numbers, break them down, reduce by dividing, and it breaks me down to 30 milliliters. If I administer 30 milliliters, I administer 1,800 drops. That's all there is to it. Alright, last one of this type. You would like to deliver 50 milliliters of normal saline. Using the given drip set, how many drops will you deliver? Now let's set it up as we go. You would like to deliver 50 milliliters using the given drip set of 60 drops in 1 milliliter. And by making sure my problem is set up right, it is. And 50 times 60, 5 times 6 is 30 with 2 zeros. That equals 3,000 drops. And that's how we do basic drips with a drip set. Just knowing how many milliliters or how many drops I need to get a given amount.